All right, mathletes, here's an example of a continuity flow chart, and it doesn't have to be exactly like this. So this is just one that I made, based on kind of my preferences and understanding all the things. So, definitely make one that fits and that works for you, that helps you to understand. So first of all, there's two, I think you could do it in 2 or 3 different ways. So one way is, I think the two distinctions you have to make is continuity at a point here, or identifying and classifying discontinuities. So they're kind of 2 different types of problems to some extent, even though they're definitely related. So continuity at a point, that's where you go through our checklist of items. Remember, there's 3 things. Is the function defined? Does the limit exist at that point? And then does the limit equal what the function is at that point, right? So remember, those are the 3 things that we've kind of talked about over and over again. And so if you're given a function f of x and they're given a point a, then if first thing you check is f of a defined. So what that means, you plug in a to f of x. If it comes out to a real number, you keep moving forward. If it's no, then that means it's not continuous, right? So that means the function is not continuous at x equals a, right? If it's yes, then you go, does the limit exist, right? So the way to see if a limit exists is you check, does the limit from the left equal the limit from the right? If it does, then again, you keep moving forward. If it's no, then that means the function is not continuous, right? So any of these no's gets you right to the point where it's not continuous, okay? But if it's yes, we keep on moving. And then the last part, if the function is defined and the limit does exist, then the last thing we check is, does the limit equal what the function is at that point? If the answer is yes, then if all those 3 things are true, that means the function is continuous at a. If the answer is no, again, then it goes to the function is not continuous at x equals a. Okay, so that's the continuity at a point part. And then the identifying and classifying discontinuities, that's a little more involved. But basically, let me grab a different color here. Basically with this one, grab pink. So with identifying and classifying discontinuities, these are kind of your directions here to some extent. And then you ask yourself, what kind of function is it, right? What kind of function is f of x? If it's a polynomial or sine or cosine, right, with just x in it or without anything in the denominator, or if it's exponential, if it's any of those, then it's continuous everywhere, right? So you can just write continuous, all right? If it's a rational function, then you check, is there a 0 in the denominator, right? So basically you set the denominator expression equal to 0, whatever that expression is in the denominator, you set it equal to 0. If there are no zeros, that means it's continuous everywhere. If there are zeros, then you plug in values to your numerator, okay? If it comes out to 0 on top and on the bottom, that means you have a removable discontinuity at x equals a, okay? If you end up with something else besides 0 in the numerator and a 0 in the denominator, that makes it an infinite discontinuity at x equals a, okay? So that's rational. Then you get to piecewise. Piecewise, you check the transition points, right? So those are the points where you go from one function to the other, right? So in this case, we're calling it a, all right? And so if you plug in a to both functions, right, h of x and g of x, those functions here, if they come out equal, if g of a equals h of a, that should be an a right there actually. So if g of a equals h of a, that means the function's continuous everywhere. If the functions are not equal at that point, then you look at, that means it's not continuous, right? But then you look at the inequalities. If it's a greater than or less than, that means it's a jump discontinuity, okay? If your symbols here, these symbols here, if these symbols here are equal to, not equal to, that means it's a removable discontinuity at that point, okay? So basically, you plug in a to both functions and see if they're the same. If they are, it's continuous. If they're not continuous. And then you just look at the symbols. Are they these symbols? like less than, greater than, or are they equal to, not, or equal to? And if it's less than, greater than, it's jump. If it's equal to, not equal to, then it's removable. Okay. All right. And then last of all, the last one that we've kind of worked with are if you have sine of 1 over x minus a. All right. So if it's one of these, then it's going to be an oscillating discontinuity at x equals a, right? And remember, the difference between this and sine and cosine here are again, that you have a variable in the denominator inside the sine and cosine, right? And so that's the difference. So be careful. Remember, if it's just sine and cosine without a variable in the denominator, it's continuous everywhere. But if you do have a variable in the denominator, those are the ones that are oscillating. They just go up and down, up and down, up and down as they get closer and closer to that discontinuity. And so they never, they don't approach anything in particular. It's not removable. It's not an asymptote either. So it's not infinite. So it's an oscillating discontinuity. All right. So that's an example of a flowchart. Just to give you one, this is one that I started where I was splitting them up in different ways. And so I think what you could do with this one is just do the identifying discontinuities separate and then the classifying discontinuity. So I think here you could do the types of functions and just kind of yes or no, is it continuous or not continuous? And then here you can talk about like, well, what makes them a jump versus a removable, or what makes it infinite versus removable, what makes it oscillating. So I think that's another way that you could go and do it that way. So again, lots of different ways to do this. There's not really a right or wrong answer. It's really what makes sense to you and what helps you to answer the questions and get to from point A to point B, really. And so remember, this is something you can use on the quiz. So it's not just an assignment for the sake of an assignment, but it's something that hopefully can help you to be successful when you approach these questions. Okay. So and again, like mine is written and I have it kind of color coded. You don't have to do that, but remember, you get points, style points, organization points. If you put in examples, that can get you some extra points as well. And so that's one thing that I'm missing on mine, is I don't have specific examples. So if I were to put some examples in there, I think that would make it even better and add some extra points. So and remember, you can make it digitally, you can make it handwritten, whatever works best for you. And again, helps you to get, to understand what you're working with and how to get from point A to point B. All right. Let me know if you have any questions.